Alright, 2021 Applied Math 6A. A particle of mass m suspended from a fixed point by a large elastic string of natural length L and an elastic constant 3 mg over L. Okay, so the first thing I'm going to write down is its natural length in black, and then there's going to be a stretch section which will be denoted in red. Okay, so the black section represents the point at which simple harmonic motion no longer exists. Is that okay? Because there'd be no tension in the string if the particle manages to go upwards beyond that point. So we're going to have the particle here, and it's of mass mg. Okay. Now, alright. So at the very beginning, the string is stretched slightly and the forces are balanced. So T upwards equals mg going downwards. Okay? And that's the first part of our marking scheme. Now, next part of our marking scheme is figuring out how to get the tension. And tension is KL minus L0. Is that okay with you guys? Now, if this is natural length L, if the black length is L, and for the argument's sake the red length is D, what can we say about this formula then? T, which is mg, equals K. What's K? Is up there. Yeah. Okay. And then what else we can say is that L, what's its current length, lads? Using my system, its current length is L plus D, isn't it? So it's going to be L plus D minus L. Now, what you can see that happens there is that the L's cancel off, and it's very simply 3 mg times the extension D. And that's where that comes from. 3 mg over L times the extension. They used E instead of D. Alright, that equals mg. Cancel the 2 mg's to leave me 1. And D is going to be L over 3. So we know the current extension is L over 3. Is that cool with you guys? Okay. L over 3. Happy days. So we're a good bit of the way down now already. So I'm just going to rub out what I have. Is that okay with you guys? Rub out what I have. Now, what happens next, lads, is we have to show that it executes simple harmonic motion. What does that always mean? You want to get it in the form A equals minus omega squared x. Show that it undergoes simple harmonic motion. Get something to do with A equals omega squared x. Is that cool with you guys? Alright. So, what we're going to do here is I'm going to extend it down another further distance x. And I'll denote this in green. Now, would everybody agree that the equilibrium position was this position here? Which was it 4L over 3? L plus L over 3 is 4L over 3. Okay? And now, remember, we're not doing its amplitude, we're just saying its generic distance, x. Any distance below the equilibrium position is what we're looking for. Is that okay? So any position under the equilibrium is what we're looking for. So, here's what we're going to do next. Okay? We're going to say that net force, which is MA. Now, which is bigger, up or down? Which one's bigger now? Tension going upwards or mg going downwards? Yeah, because you pull it downwards, which means it's about to go upwards. So we need a negative answer. So do we do weight minus tension, or do we do tension minus weight? Which one will result in a negative answer?
Weight minus tension.
Exactly, weight minus tension. So it's mg now minus tension. And what did we say about tension earlier? It's K times L minus L0. Okay? Now, what's the current length of the rope? 4L over 3. So I'll use a black dot. 4L over 3 gets you from here to here. And then the extra distance x gets you from there to there, correct? So what we're going to say is that it's 3 mg over L for the K value. Its current length is 4L over 3 plus x. Take away its starting value, which is minus L. Is that cool, you guys? And you'll just get L over 3 plus x, which we saw already knew. What always has to happen when you do this? What generally always happens? What generally happens is you can only have, remember we said a equals minus omega squared x. You're only allowed one thing, and it must have x as a variable and a coefficient in front of it. There can't be anything else. So I'm fully expecting that mg to cancel, which it will. Mg, 3mg over L multiplied by L over 3 is your minus mg. I was completely expecting that to happen. And then we get minus 3 mgx all over L. And there's our A. So we're pretty close. Oh, sorry, it's MA. We're pretty close to having this part of the marking scheme done, which will give us, there's no actual marks on it. Yes, pity. Alright, let's keep going. Now, what we're going to do next is cancel the m's. And we have A equals minus 3gx over L. Is that cool, you guys? Minus 3gx over L. This means it executes simple harmonic motion with omega squared equal to what, lads? What's the omega squared equal to? Would you agree it's the 3g over L? Remember, A equals. So, we all cool with root 3g over L? Okay. Now, what else does it want from us? We did that. Okay, happy days. Oh, this is interesting. Okay. What do we know about the amplitude, lads? What do we know about the amplitude? 2 over 3L. So, it's simple harmonic motion with omega equals 3g over L and amplitude of 2L over 3. Is that cool, you guys? Now, what we're going to do next is, I'm just going to rub out all these workings because I don't really need them anymore. Okay, and I'm just going to bring up my new information onto the top. It's a nice tidy question actually for a part A. There's nothing too crazy going on about it. Now, alright, first question we got to look at. Is it a time question or a distance question? Distance. So we don't have to be concerned about how long it took to get there. Does that make sense? Okay. Now, just going to rub out a few of these bits and we're going to see where we're at now, right? So, would everybody agree at the beginning of its motion, would everybody agree that we're 2L over 3 underneath the equilibrium position? Is that okay? So at the start, at t equals 0, at distance travelled equals 0, and at an x value of 2l over 3. Do you notice the way it's a plus 2l over 3? Yeah? Now, where do we have to end up? How far out the other side do we have to end up before the string goes slack? We have to travel 2l over 3 to get to the equilibrium position, and then we travel another l over 3 until the tension is gone. I would say that that is an x value of minus l over 3 because it's out the other side of the equilibrium position. Does that make sense? The x value refers to your position compared to the equilibrium position. Currently, if you're below, that's a plus x value, and if you're above, that's a minus x position. Is that okay? Now, next thing, let's check our equations. I would love to know what the velocity is at this point going upwards, and then I could do linear motion to determine how high it gets above the equilibrium position. Okay? Now, we know the answer is going to be L over 3 plus something. How do I know it's L over 3 plus something? How, at this point here, how far above the equilibrium position are you?
L over 3.
Exactly. And we have to find out what distance it travels without the tension in the string. To do that, we need the velocity right here. I think there's a nice formula for us, isn't there? What's it called? Phi squared equals omega squared a squared minus x squared. You can sort of see that the marking scheme sort of jumps a step and isn't quite as useful as it would normally be. So we will square root both sides eventually, right? Now what's the omega value? We square that, don't we? And we get 3g over L. What's our amplitude? 2L over 3 squared. And we get 4L squared over 9. What's our x position? At the point where we're looking for this velocity?
Minus L over 3.
Yeah, because we're squaring it, if you actually did put in L over 3, you still would have got the same answer, but arguably you still could have got marks removed from you because you were wrong. Okay. Do you have a question for me? Now, would everybody agree that phi squared equals 3g over L, and then that's 4/9 minus 1/9, which is 3/9, which is a third. Okay. And what else will cancel now? I think we're sort of in business now. The 3 cancels. The L cancels with that. And I get phi squared equals GL. Or phi equals root GL. No, you'd be remiss if yeah, we're all good. We're perfect. Alright, no mistake made. Alright. Now, I could square root that, but I'm just about to use phi squared equals u squared plus 2as. So I'm not going to bother. That's okay with you guys? Now, what do we know about this? Now, here might be the confusing part. Actually, I will square root it. I'll explain why. If I do uvast, what's the u value when you're at this point here? The v value of your last part is the u value of your next part because you're traveling upwards and gravity is about to slow you down. Okay? So we have u equals root GL. V is what, lads? It's the highest point of its motion. 0. A? Or yeah, I'll go minus g because there's a g already there. But yeah, you're not wrong. And our s value is what we're after, isn't it? And the t value we don't even need. So we're going to go for phi squared equals u squared plus 2as. Okay? And I will get rid of that. Give myself a bit more space. And off we go. Alright, let's do this. So we got 0 equals square that. We get GL. 2as is minus 2gs. 2gs equals GL. S equals L over 2, which is perfect. And what did we say earlier? We're going to add on L over 3 to L over 2, which is 5L over 6, and that'll be full marks, please. Right? All good.